Boom! Yes, folks, how are you going? So in this video, we continue with our division, with our factorization of polynomials. And as you would see on the board there, we're moving up from powers of 2 being factorized into individual powers of 1 into factors, into polynomials of power 4. Right? So we have a question that says, given that x squared plus x minus 2 is a factor, very important word, of f of x, where f of x is equal to x to the power of 4 plus 2x cubed minus 13x squared minus 14x plus 24. Factorize f of x completely. Another important word. Excuse. So let me talk a little bit about what they mean when they talk about factorizing completely. Anytime you do a question and you see the instruction and the instruction is to factorize completely, then tell yourself that at some stage in the working of the question there will be an incomplete factorization. So this is where you had to read between the lines. You had to pick sense from nonsense, as we like to say in the Trinidad and Tobago dialect, right? I am sure there are equivalent phrases in other territories, but that is how we say it in Trinidad and Tobago, right? You pick sense from nonsense, you read between the lines. And all of this goes back to the heart of the whole question of reading problems and comprehension and extracting information from a question. All right? So that is also an important skill when you're doing maths, right? Your English, your comprehension, your ability to read a question and pick the important information out of it, even though they didn't tell you directly. That is an important skill. That is something that you will develop and hone and make better by practice, by doing exam level questions. You get familiar with the vocabulary, you get familiar with how they say stuff, so that when they tell you that something is a factor of another thing, it means that if you divide this by this, you would not have a remainder, right? You see how the vocabulary coming in again, and it kind of hinting now that at some point we will be dealing with division where we actually do in fact have a remainder. That is where we get into the remainder theorem and the factor theorem, but that will come after this little piece of work we're doing here. Similarly with the factorization of complete factorization. Remember, and I'm going to talk it out now, so I want you to pay a careful attention to what I'm saying here. Remember in a video about 2 or 3 videos before this one, we would have discussed the factorization of, I think it was 1 minus k to the power of 4, right? And we said that that is a difference of 2 squares, where 1 minus k to the power of 4 is 1 minus k squared multiplied by 1 plus k squared. So if they tell you factorize 1 minus k to the power of 4 completely, and your response to that is that 1 minus k to the power of 4 is 1 minus k squared into 1 plus k squared, then you know you wouldn't get the full marks, right? So if they tell you factorize 1 minus k4 completely, and you do that, tell yourself that if the question is worth 2 marks, you only have 1 mark to get, because at that point this factorization is an incomplete factorization. We still have to finish the work, which is to now take 1 minus k squared and get 1 minus k into 1 plus k into 1 plus k squared, right? So I just demonstrate the concept here only to say that we're going to apply it across here now. All right, so there we go. So we're going to now divide this long guy here. We say in x to the power of 4, x to the power of 4 plus 2x cubed minus 13x squared minus 14x plus 24 divided by, watch it now, x squared plus x minus 2. So whereas in the previous videos we would have divided a quadratic by a linear to get another linear on top, in this case we divided a polynomial of degree 4 by a polynomial of degree 2. And we know that if we do that, what we expect to get here in the quotient would be a polynomial of degree 2. Right? Remember, in one of the very early videos we said that if we multiply a quadratic by a quadratic, which is power of 2 by power of 2, the answer will be a power of 4. You just add the powers. Right? So if you divide a power of 4 by a power of 2, you will get a polynomial expression of power 2. So we have an idea of what we expect to get. The next step now is to execute and actually get it. So we divided. X to the power of 4 divided by x squared is x squared. Alright? And then we multiply this x squared by everything on top, everything here. So x squared by this would be x to the power of 4. X squared by x squared is x4. X squared by x is x cubed. X squared by minus 2 is minus 2x squared. Alright? And we go in. So we minus it now. So x4 minus x4 is 0. 2x cubed minus x cubed is 1x cubed. 1x cubed? Yeah, 1x cubed, right? Minus 13 minus 2. Now at this stage, I will leave it up to you who watching this video to take your pen and paper and write it out. I will call it out. You write it out, because I don't want you all to get into the habit of just doing things mentally just because you could do it. You're under exam pressure. It's always better to be cautious. Alright, and that is something that I will be repeating as we go along. So if you're in the exam and you're doing this and you have any doubt at all, then go in the corner and write it out. If you have it snappy like that, then okay, fine. Just make sure you get it correct. Alright, so minus 13 minus minus 2 is minus 13 plus 2. Minus 13 plus 2 is minus 11. So you get minus 11x squared. And at this point, we can leave it like this. We don't need to bring down the minus 14x here, because we will just be dividing here. Actually, no, we need to bring it down because we have 3 terms here. Alright? So we have minus 14x here. So x into x cubed is x cubed. Sorry, x squared into x cubed. You see? Again, you see what happened there? My mind, I write x squared here and I put my finger here and I call x. It's just a question of familiarity. Right? So now I myself have to break out of that shell and realize that, hey, we divided them by a quadratic. Alright? So x squared into x cubed is x. X multiplied by all of this. X by x squared is x cubed. X by x is plus x squared. And x by minus 2 is minus 2x. Good? So we're minusing again. X cubed minus x cubed is 0. We leave that out. Minus 11x squared. And again, if you need to, go and write it out. Excuse, right? Minus 11x squared minus x squared is minus 12x squared. Minus 14x minus minus 2x minus 14x minus minus 2 is minus 14x plus 2x, which is minus 12x. Minus 12x, and then you bring the plus 24 down. So x squared into minus 12x squared is minus 12. And so minus 12 by x squared is minus 12x squared. minus 12 by x is minus 12x, and minus 12 by minus 2 is plus 24. So you're minusing, boom, 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 and boom, boom. All right? So just as advertised in the worded question itself, when we divide all of this by this, we get this with a remainder of 0. And that is what it means when they say that this is a factor of this. All right? So anytime you see the word factor, tell yourself that the remainder is equal to 0. So if they ask us to factorize completely, we're going to rub this off now and write it out. When they say to factorize completely, it means then that the very next line, having completed the long division, we could say immediately now that we could say therefore, right? We could say therefore x4, no, let me leave it as f of x, because that whole thing is f of x, right? Therefore, f of x, you have to find nice, elegant ways of shortening the thing to when it could. All right? F of x is equal to, watch it now, x squared plus x minus 2 multiplied by x squared plus x minus 12. So in other words, you factorize this and you get this multiplied by that. That is factorization. You break up some entity into its constituent factors, and you could go and look up the meaning of the word constituent for your English. Constituent is not just about elections. All right? The word constituent has a particular meaning in the English language. All right? It talks about something constituting something. All right? But as I say, go and check it out. Right? So you see you're learning some English in an AdMath session too, right? We're doing it nice. Okay? So this multiplied by this. Now remember, the question had said explicitly to factorize completely, which implies very strongly, there's a strong hint that even after you do all of this and you get this, the factorization is still incomplete. Now, if they tell you to factorize completely, then tell yourself that these two expressions could factorize, or maybe one of them might be factorizable. So you might very well get a situation where you get an expression of power 4, you factorize it and you get two quadratics, and only one quadratic could factorize into two linear factors. Just like how when you had 1 minus k to the power of 4 and you had 1 minus k squared into 1 plus k squared, and you was only able to then factorize 1 minus k squared into 1 minus k by 1 plus k. Now as it happens, the factorization, these two could also factorize into two linear factors. All right? So when you factorize this, you will get now, this will be x, right? This will be 2 and this will be 1. This will be plus 1. This will be 2 minus 1. So it will be plus 2 and minus 1. Right? So this will be x minus 1 into x plus 2. Notice how fast I'm going through this, right? This is AdMaths. This is not maths. If we were doing CSEC maths, I would have taken my time and go through this and do the A by C and any blah. No. We do that in maths. So if you need to brush up on that in maths, go in the maths platform and do that. If you come in here to AdMaths, tell yourself that when I'm working out this, it's boop, 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 bap, 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 bam. AdMaths is what we're dealing with here now. Right? Same story over here. X squared plus x is minus 12. That will be x. 4 minus 3 is 1. So that will be plus 4 and minus 3. All right, 4x minus 3x is 1, 4 by minus 3 is minus 12. So now we have a complete factorization where f of x is equal to this, x squared plus x minus 2 into x squared plus x minus 12. And then you break up each of these quadratics, listen to the language now, into its constituent linear factors. So you factorize here now. So this will break up into x minus 1 into x plus 2. And this will break up into x minus 3 into x plus 4. So that the final answer would be x minus 1 into x plus 2 into x minus 3 into x plus 4. So you see now, just as I would have mentioned, maybe it was in the third or the second video, somewhere thereabouts, that you have a polynomial of degree 4, which you could factorize or break up into two factors of degree 2. Degree 2 multiplied by degree 2 will give you a degree 4. And then you come here and you have degree 2 by degree 2. You take this degree 2 and you factorize it further into degree 1 by degree 1. Right? 1 plus 1 is 2. And you take this polynomial of degree 2 and you break it up into degree 1 by degree 1. So you now have, in the final analysis, a big long macro polynomial of degree 4. And when you do all your working, you end up with 4 polynomials of degree 1, more commonly known as 4 linear polynomials. So if you multiply 4 linear expressions by each other, tell yourself that you will get an expression of degree 4. All right? So I just want to reiterate that when you're going through these guys here, you see this? You have to be so careful with your minus signs. It makes all the difference in the world. So you cannot afford to make a mistake in here. Because if you make a mistake in here, then your ability to proceed with the problem is constrained. The nice thing about the question though is that in this case, they would have told you from the beginning that x squared plus x minus 2 is a factor of all of this. Which means then that if you're dividing this by this, you know that you're not supposed to get a remainder here. So if you get a remainder here, you know immediately that you would have made a mistake somewhere inside here. So this is another example where you use the language of the question as a guide, as a signpost, so to speak. So that you expect certain things to not happen and you expect certain things to happen. So if these certain things that they're expecting to not happen, you know something wrong. And in some cases, if the things that you're expecting to happen not happening, then something wrong too. So all of these are ways in which you could monitor your progress as you go along. So if they said, as they did here, that this is a factor of this, and they do a division and they get 0 here as a remainder, then at that point you could tick and say, all right, I know I'm going good so far. So the next step now is to follow the instruction now where they say to factorize completely. And that is now where you're going to do the extra factorization here. Factorize, boom, bam, factorize, boom, bam. All right? So I'm going to do one more like this, one little twist, which you will see in the next video coming up. So check it out. It's coming up right after this one.